Happy Monday, Flutter friends! Today we're gonna host a very special event by Filip from the Flutter team. Uh, the special thing about this event is an event that it's been organized by multiple communities around the US instead of just a single community. So I really want to thank Nile for putting this together and Philip for actually doing the talk. He's going to be talking about how to optimize your Flutter application. I've seen this talk or a similar version of this talk in Flutter Europe in Poland, and it was amazing. So I'm very sure that you're going to learn a lot. Before we proceed with the event, I would like to send a big thanks to Flutter NYC and Flutter San Francisco, as well as the folks in Flutter Chicago for taking the lead in organizing this event, but also our friends from Flutter PDX from Portland, Flutter Denver, the Flutter Devs Group in Orlando, the GDG Capital Region Group, and the QC Flutter Group from Charlotte, because they will be live streaming and joining for this event as well. My name is Jorge Coca. I organize the Flutter Chicago Meetup, and I hope that you have a great time tonight. Have fun, everyone. Happy coding.
Hello everyone, I hope you can see me. My name is Filip Hracek. I'm a developer advocate on the Flutter team, and thank you. First of all, thank everyone for tuning in. I know it's probably late where you are, or maybe not, but anyway, you're giving me and Flutter over 1 hour of time, which is amazing. And I also want to thank everyone, Jorge, Mariano, Martin, Nilay, everyone who have been organizing this or like who have worked on making this happen, because it's a lot of work, and also they're amazing people. So that's cool. I've been doing different kinds of presentations and meetup things for well over 10 years now, and I have to say, this is the first time I am doing a meetup presentation to several time zones at once, and that's pretty humbling, and I hope that you all have a good time. It's also the first time I'm giving a presentation while not wearing pants. just kidding, okay? I'm kidding. I am wearing pants. But just, okay. I'm wearing pants, okay? All right, so this is a talk about performance, and this is right up my alley, so to speak, because I am kind of, I guess that's the thing that I do in Flutter is I do boring topics. I was doing state management. Maybe you've seen some of my videos from the past. I recently published an article about like animations deep dive, so the things that are like way below all that stuff, the amazing animation stuff that you hopefully use and love in Flutter. And this time around, I'm talking about performance, and I'm saying this because I feel these things are important, even though they are boring. I also understand that for most people, Flutter is this amazing thing, and for me as well, Flutter is this amazing thing that is kind of like a canvas. It's a very expressive framework where, because it's so low level and it's so fast, you are able to do whatever you want. You have complete control over every pixel on the screen, for every frame. And that's very liberating, and you can really do amazing stuff with this, right? And here I am being like, oh, have you thought about state management, or have you thought about performance? And I kind of think it's yes, it's kind of a downer to talk about this kind of stuff, but it's also very important, because however nice your application looks, however amazing like palette and animations and typography it has, once it is not fast, once it drains battery or it crashes because it takes too much memory, then all of your work is kind of down the toilet. So that's why I think it's important, and that's why I think all that is. Let's just talk about it. I'm distracted by the live chat, by the way, so this will be terrible. I will just probably ignore that for the time being. So just so you know, we will go through this presentation. It has a very big element of live coding in it, or live profiling. And at the end, we will have some time for questions and answers. If you have questions and answers, you can still put them in the chat, but I will probably be ignoring them for now because I'm really bad at multitasking. And if I'm trying to talk, I cannot look at anything else. All right. Let's. I hope that you can all see my screen. Probably yes. So what we'll be covering today is performance, and in 3 steps: terminology, things that you should probably know what it means. Then some kind of basics that you should know about, and tools that the Flutter framework provides for you. And then lastly, the live profiling. And then we have a Q&A. I should also say, before we delve into terminology and the actual meat of the matter, I don't want to scare anyone off because this might get a little technical, a little, for some people, it could be a little, not super usable and not super cool. And so if you're just starting with Flutter, or if you have never had any problem with the performance, which is quite probably, then you don't really need to know this stuff, and you will probably just kind of skim through it, and you don't need to go too deep into it, right? Flutter is fast by default. As I said, it goes very low level. It lets you basically speak directly to the graphics card of the mobile phone or whatever you're using. So don't let this be like some kind of way that give that limits your creativity with Flutter. Don't think that you need to know all this for your apps. For many apps, they are just fine, just using everything that you're already doing, and you don't need to worry about it. If you're trying to squeeze that much more performance out of every device, then this might be interesting for you. And obviously, if you do have a performance issue that you know that is an actual performance issue, then this might fix it. No, not really. This might help you, maybe. Okay. So that's probably it. Okay, so let's go to terminology. Okay, so I should also say, to kind of underline the theme of this presentation, I have decided that every animation in this presentation is going to be excruciatingly damn it, I can talk. It's gonna be very slow. So enjoy this super slow and super annoying animation of a sloth disappearing into the void. I'm imagining you laughing now, although I know that you probably aren't. Anyway, jank. So jank is something that is a word that I probably didn't know 5 years ago. And it's basically if you imagine an animation, like, a dialogue window sliding from right. Is it right for you? Yeah, sliding from right. So if everything goes well, it just does this, right? If there's jank, it does something like, right? So jank is when things are normally okay, they're fast enough, but there's missed frames, or there's some kind of discontinuity in the motion that is happening on the screen, right? In some animation. And this is super jarring. It's not very pleasant to look at for people. It is like, it kind of takes away the feeling that most apps and most operating systems these days try to evoke in you, and that is that of a physical presence or physical space, right? So there's a reason why we like when scrolling kind of looks as if it was a physical thing. There's a reason why the Flutter framework has a simulation class in it, because that's how we kind of scroll things, how, drag and dropping kind of starts and ends. It needs to be, things cannot be mechanically just like dragged around in linear curves and stuff like this. They should be more smooth, as if they were in real life, right? And probably the worst thing that can happen to this imagined real life physics thing, where you're like sliding something on an icy table or whatever, is when it suddenly stops and then restarts a few seconds, or well, hopefully less than a few seconds, a few frames later. That's what we call sometimes missed frames, when like the framework cannot keep up, or your app cannot keep up with the demand, and it has to not draw some of the frames in the sequence of like 60 frames per second or 120 frames per second. So I remember when apps were slow in general. Like I remember where like if there was a slow app, everything was slow. So like even moving the mouse from left to right was slow. Every input had like half a second of delay, stuff like this. That's no longer the case. Even the worst offender app is generally mostly fast. Like, things are scrolling and everything. But there's sometimes, for bad apps, regardless of framework, there's jank. And that's what we try to avoid. So that's what we'll be looking at a lot. All right, UI thread. So you might not know, but Flutter app, even the simplest Flutter app, is already multi-threaded, as in like it runs on several cores of the processor of your device. So if I just use the sample app with the counter, that is the UI thread, which is what you normally look at. I'll come to that later. Then there's the raster thread, formerly known as the GPU thread, which we renamed recently, and it still says GPU thread in many places, but I'm working on it. The GPU thread is, or the raster thread is we changed the name because it was confusing, because most people assume that the GPU thread is running on the GPU. That's not the case. The GPU thread was called the GPU thread because it is still the raster thread is talking to the GPU. It's the thread on the CPU that is talking and sending bytes and instructions to the graphical card, basically graphical processing unit, which then paints the pixels on the screen. So a pretty important thread, but it is separate from the UI thread. And then there's an IO thread, which is something that whenever you're loading images from the disk on the device, it will be using the IO thread, so that the GPU thread and the UI thread are not being used for that kind of stuff. And then there's a platform thread, and then you can, as a developer, and we'll be actually doing this later today, you can create your own thread. So you can, what we call an isolate in Dart, which is basically a thread. You're using a different core on the CPU than everything else, and then you don't block the UI thread. So anyway, UI thread is the thread where your main method is. That's the thread where run app exists. That's the thread where you're creating and building your widgets. Basically, if you're not doing any performance intensive tasks, then you can completely ignore threading in Flutter, because you're basically every time you're in the UI thread. So again, where this talk is about when you're doing, when you're not doing that kind of stuff, but you're trying to do something more. Tracing in performance is, in the context of performance, is when you're trying to find out how costly something is in terms of performance. Like, for example, how long does it take to compute something? So you can do this manually. Normally in Flutter does most of the tracing for you automatically, like, all your build methods are traced and stuff like this, but you can completely use do this manually by just import dart colon developer, dart colon developer, and then using the timeline here to timeline.startSync creates a new event, and timeline.finishSync ends it. And this tells the profiler that, oh, there's a computation that started here and ended here. And later, and we'll be talking about that later, you can look at this and be like, oh, this computation took so much time. And then you can look, oh, okay, so this is why. You can put more timeline events there, and so on and so forth. So you generally don't need to know about this kind of stuff unless you're doing some, again, very intensive task and you try to find out exactly how taxing it is. But I think it's nice to see that is basically what the Flutter framework is doing, for example, for build methods, right? So if you imagine that this is your build method, this is what happens, kind of. Okay, so tracing. So now that you have all these events that, like, my computation starts at this time, exactly this time, and finishes at exactly this time, it makes sense to put them on a timeline, right? And say, oh, so we started at this point, we ended my computation at this point, so the whole computation took 0.8 milliseconds of a core of a CPU, right? That by itself, it doesn't tell us anything, but like if it's was supposed to be a pretty substantial computation, then we're probably happy, because we have, in a 60 frames per second app, we have 16 milliseconds to do stuff. In 120 frames per second app, we need to do everything in 8 milliseconds. But this looks like, okay, if my computation was actually something very simple and something that we need to run several times per frame, then this might be a really bad result, right? But the main thing is that now, thanks to tracing or profiling also, we can see what that time is, right? Flame chart. So one thing about this is, oh, this is cool if you have one computation in your app and you have this kind of timeline. That's cool. You can look at this and immediately know what's happening, right? But most apps have many different computations that are nested and overlapping. So if you use the naive timeline, you would get something like this, like, oh, we started build here, and inside build we had a foo method here, and then we ended foo here, and then we ended build here, right? And you can imagine, if it's this complicated with 2 methods, imagine like 100 methods. So someone very clever invented what we call flame charts, and these are basically saying, hey, instead of just having one single line and putting the events that happen, on the CPU or whatever during that time, we'll use bars that represent that computation. So in this case, this is equivalent to this. So build started here, ended here. Foo started sometime inside build here, and it ended here. Not sometimes, exactly here. It's and so that's very helpful, because you can immediately look at this and be like, oh, okay, so foo is taking a long time. It's taking almost 80% of build. What's going on? I can look into it more. A more real life flame chart looks kind of like this, and that's, as you can see, many events all at once, but you kind of see already, oh, okay, so this is a frame. We were doing layout most of the time, and we were building these widgets, and the first one took a long time, and there was all these little, scrollable, list view. You can see all these things. Imagine it in a single line like that. That would not work. And another terminology, the last one, but it's probably obvious, but in performance especially, trade-offs are necessary. Trade-offs is when you need to make compromises between two things, right? So you can totally have a bug that is making your app slow and non-performant, and then just fixing it, there's no trade-off. You just fix the bug and everything is faster. Great. But in many cases, you have trade-offs. So if someone's like, oh, I want to make sure that the app uses less memory, then you often need to use more CPU because maybe in the memory you had something cached and now you don't, so you have to recompute it every frame, right? Or you could totally avoid jank somewhere, but then your app consumes more battery. All these things. So you never think that there is just one easy way to do stuff. There's always, you have to think about this, and you have to kind of know that almost everything that you do to your app is gonna be bad for something. The most obvious trade-off that I forgot but is complexity versus speed, right? So you can definitely often make some build method or some function much faster, but it's also going to be a lot more code, a lot more complexity, much worse to debug, maybe containing bugs from the get-go, right? So you often want to be like, oh, okay, so I can make this 5% faster, but I will make this 10 times more difficult to understand. Is it worth it? And that's why Flutter is trying to kind of be fast by default. You can totally, like, what you do in Flutter is like you build every frame. You can just rebuild your UI from scratch, right? That's definitely making things easy for you. And Flutter framework in the background will make it fast for you, but it's not requiring you to do a lot of the work that you would normally do with a UI framework. All right, so we're at number 2, tools and basics. I'm hearing that things are echoing. I hope not, because I don't know. Hopefully it's not echoing. Anyway, today the next one is tools and basics, right? All right. I'm not sure if this is working as a joke, so let's go. Imagine we're working together, you and I. We're working together on an app. It's called the Sloth app. And I find out that it's not performant enough. It's slow, or it's janky, or whatever, right? And I come to you with this, what you see here. And I tell you, hey, let's have a look at this and look at how performant or non-performant it is, and let's kind of troubleshoot the performance there. At that time, you should be like, no way, this is bad. You should just shut me up because I'm doing 2 big mistakes right here. The first one is that I'm trying to debug or troubleshoot. I'm trying to troubleshoot or profile the app in debug mode. Debug mode, so Flutter apps can run in 3 different modes: debug, profile, and release. When you release your app into App Store or whatever, it's running in release mode. That's the fastest. Profile mode is almost as fast as the release mode. It just spends a couple of more things to make sure that we, for example, record the timeline so that you can then look at the flame chart, right? And then there's the debug mode, which you use normally in developing your app, and it's slow. It's not just uniformly slower than profile mode. It's some things in debug mode are like, let's say, 100 times slower. Some things are almost as fast as in profile mode. So if you're looking at an app in debug mode and you're like thinking about performance, don't. Just like compile it profile mode, and don't even look at the debug mode. That sometimes sucks because you want to be like immediately know, okay, so if I add this and you hot restart, which you can only do in debug mode, you hot reload or hot restart, you want to see, is this performant enough? Don't do it, because you might be led to believe that something is not performant at all, when in fact, when you release it, it's gonna be just fine. It's gonna be super fast actually, and you wouldn't know, right? So never look at debug mode when in terms of profiling performance. And the second problem that I have here is I'm using for profiling, I'm using the emulator or simulator. This is bad for a very similar reason as the debug mode. So well, actually you can't even run profile mode in the emulator. I don't think we let you. But even if you did, that would be a very bad idea, because emulators and simulators are emulated. They're not the real thing. Some things are much harder for the emulator to do than the device, what the device does, right? And some things are much easier for it, because it's like it's a computer. It doesn't need to worry about battery and stuff like that. So again, don't look at your some things actually, yeah, some things are terrible in the simulator or emulators like Android Studio emulators, and then you run them on an actual device, even like an old device, and they're just fine. So please don't do that. And that's kind of the, we're talking about basics. This is a basic thing that I see a lot of people kind of forget about a lot of the time. So don't do that. Next basic thing is avoiding work in the UI thread. Kind of obvious. The UI thread is, as I said, is where all the building and kind of layout is taking place for the framework. This is where you're, creating your widgets and stuff like that. It is not that easy actually to do too much work in the UI thread, but if you're not aware of the fact that the UI thread is really the only thing, it's kind of a bottleneck for the framework, then you might get in trouble. So for example, I'm not sure if I already made that example, but let's say, so what the UI thread does is every, let's say 60 frames per second, right? So 60 times per second, it will kind of wake up and be like, oh, let's work on the next frame of the animation or whatever, assuming there's an animation. Sometimes there's not, and in that case, the framework does nothing. If there's an animation, it wakes up and is like, oh, we have only 8 milliseconds to build the next frame. So let's get going. And it will do it in hopefully way less than 16 milliseconds. Did I say 8? Way less than 16 milliseconds, and then it's all done, right? The problem is, let's say you decide that in the main thread, in like a build method or something, you are going to like compute pi or I don't know, parse a huge XML file or do some really, really long-running performance-intensive work. What happens then is that and if you do it in a kind of synchronous manner, so you're not never returning, it's just like one big for loop or something, then what's gonna happen is that you will take over the thread and you will just do it, like, let's say for 2 seconds, you're just parsing that XML file, like for the whole duration. And then the UI thread will never get to even wake up and be like, oh, there's another frame for that whole 2 seconds. So what the user sees, the user sees a completely frozen app that does nothing. It doesn't scroll, it doesn't like update any animation, nothing for 2 seconds. and then it kind of wakes up. Terrible idea. And obviously it generally is not 2 seconds, it's a few, like even few tens of milliseconds will skip a few frames, and that's not nice. So don't do a lot of work in the UI thread, I guess. Even if it's not in the build method, just don't do it. Minimize use of expensive widgets. There are some widgets like blur or like lots of shadows overlapping where, and we'll get to those, where they're just like a lot of work for the raster thread, and you can still use them, and they're used all over the place and it's fine, but if you overuse them, then you might get into performance trouble. So it's good to kind of understand what's going on and how some widgets are not created equal. All right, when you're doing any performance optimization, it's very good to learn about the performance overlay. This is just a little widget that the framework can show on the screen for you that kind of shows you the UI thread and the raster thread. It says GPU here. So raster, the blue bars are the time it took to render each frame. So right now, like the last frame was, or the average frame is 3.6 milliseconds. Great, it's under 16, right? Here the same thing. The raster thread is also doing fine, but look at that. There's one big line that goes through all these things, and it's 68 milliseconds. That's really bad. We probably skipped like 3 frames. I can do maths now. Sorry, more than 3 frames probably. So you look at that, and it generally, paints it red. When it happens, it's red. It's not green. So it's very easy to like just at a glance see, oh, I'm actually janking. I'm making janks. Track widget builds. I don't think I will actually have time to go through tracking widget builds. That's the only thing that I'm going to talk about today that happens in debug mode, not profile mode, and it's just doing. It's an easy way for you to go through your app in debug mode, and you can just go to Flutter Performance, like assuming you're in IntelliJ or Android Studio. I think similar things exists for VS Code, but take it with a grain of salt. Anyway, what you can do is you just go through your app and you look at this widget, which is in your IDE, and you say, okay, this is actually looks really good, because in the last frame we only built 4 widgets, right? And as you go through this, you'll see, in the current screen we created this many widgets and stuff like this. This is like an accumulator, and this is just the last frame. And sometimes you will see a widget being built like 200 times for every single frame, and that sometimes tells you that things like maybe you didn't expect that. And then you can look and see what's going on. The IDE will also like show it in the actual code. So as you're reading the source code and as you're using your app, can you see that? As you're using your app, you will see next to the source code of like widget, it will show you a little yellow thing that, I'm rebuilding this. And as I say, it's sometimes like, wait a minute, we're rebuilding that? All right. DevTools is something that we'll be using today, so I don't need to talk that much about it, but it's very easy to get working with it. Observatory is something that just a few months ago I was using, but DevTools is now way better, I think. So if you're like old school, then you can still use Observatory. That's like an old performance optimization and kind of or VM inspection tool. DevTools is more geared towards, Flutter. So that's cool. And then another tool that you might not know that you actually have is a high-speed camera. So phones like this, any phone that you can find on basically any device today has a high-speed function, or what they call slow motion thing. And that's sometimes really nice because you can take a video of your app as you're working on it, and just like, scrolling left and right, and sometimes you will not see things, or you will be unsure if there was a jank in real time, but when you use the high-speed camera on your phone and watch the video, the slowed down video like this one, later, you can look at it and say, oh, okay, so there was actually a jank, or maybe there wasn't, and it just was in my imagination. If you're wondering, there is no jank here. It's just slow because it's in slow motion, and you can see every frame going there. If there was actual jank, this is 8 times slower than real life, I think. If there was actual jank, then you would definitely notice. Okay, I think that's time for live profiling, which is the cooler part of what we're going to do. So let's switch to that, and I'm still trying to ignore everything here, and just looking here. Okay, things are going well. This is the kind of content that you sign up for. All right, I think we need an IDE possibly, and also the app itself. You're not seeing anything. All right. Okay, so I made an app, and wait a minute. Now that I think about it, I think I wanted to still talk about some stuff. Oh yeah. Okay. All right. So back to the presentation. Sorry. Terrible. All right. So I made an app, and the app is intentionally bad. Okay. That's just something that I'm really good at doing really bad apps. And it's called the Sloth app, and it has several performance issues, and it's running over here, right? And we'll be looking at this app, and we'll be not in debug mode, right? In profile mode, and we'll be performance optimizing this app and looking at different issues. I do this because I want to not just be like, oh, this is the tool that you would use for this and so on, but I want to give you actual, usable, almost like, I want to give you something like experience, right? In the end, I think the best you can do for learning how to performance optimize anything, and again, it's not just Flutter, is just doing it. Like there's kind of this kind of art and science to this, where you can hear many talks about the topic, but unless you're actually troubleshooting the performance issues that you might have, you will not know. All right. There's caveats. So in this talk, I have an app that is full of performance issues, right? So in this talk, it's like, hey, find the needle in the haystack, and it's like the haystack is super small, and there's the needle, right? It's very, very easy. In real life, it's gonna look like this. It's like, oh, there's maybe 1,000 needles in this haystack. Nobody knows. Go figure it out, So I want you to understand this. It's not that easy in real life. I am dumbing it down because I don't want to spend 8 hours just like going through a real world app and trying to figure out what things are, or like explaining to you what things are bad and not. So the examples that I will have are very, very simplified and very, very kind of like ideal examples, right? Also, most apps, this app is like 50% of the code in this app is the problem. Most apps have 99% of the code is fine and just 1% of it is the problem. So that's why I'm using that. Another caveat, please avoid premature optimization. This is basically, I said it at the beginning, I'm saying it now, I'll say it hopefully at the end. Don't try to optimize stuff before you actually know it's a problem first, and then don't do it without measuring. Because oftentimes, and it's kind of like almost everyone does this has this issue, is that people will go through hoops to optimize an app and optimize one single like method that is only called once in a frame and it takes 0.001 milliseconds. And they will make it very complex, they will introduce some bugs, they will spend 4 hours on it, and it has zero effect, right? And we all do it, and we're all prone to it. So please always remember this slide. Remember that you should not ever optimize prematurely. This leads me to measure, right? So it is often the case that you see, oh, this could be cached, and you just do it, and then you leave the code in, and you're like, yeah, I made it better. But if you actually measured it, you would find out that, well, you cached it, and there was some other overhead somewhere else, or like the GC is making things worse or whatever, and it's actually worse than it was before, but you didn't measure, so you don't know, right? Or it is better, but by 1%, and the trade-off is way worse. So always measure. Like if you see a performance problem, get the measurements before and then start working on it and find out what's after that. I have not a talk, but I have an article on Medium about this performance testing of Flutter apps. There's probably better articles out there by other people, so I'm just talking about myself. But this is basically about like how do you this is again goes a little bit too into detail and boring stuff, but it's basically how would you automate this and how would you make sure that it's really like you're actually measuring what you want to measure, right? And it's a long article, and at the end of it, what I'm talking about is this kind of like automated going through one app many times, like 100 times, measuring performance for each of the walkthroughs, finding out what the different statistics are, and then measuring that against an improvement or not improvement, with little error bars and all that, All right. Finally, we're getting to the app that I showed you. So let's do some magic here. Yes. So the app we'll be talking about is this. It's on GitHub, Sloth app, and so just in case you want to give it a try at home. And once again, I'm gonna show you that this is an app that is running on a phone. So this is not a simulator, emulator, or anything like that. The thing that you see on the screen, this is actually running here. I'm generally, you would not, if you're not presenting to people around the world, you would not use something like this, because this is actually making, obviously everything on the device is slower because it needs to also send every output through a USB to the computer and encode the video or whatever. So generally you would just want a good device, hopefully one of the slower devices on the market, and but a real device. All right. So, but if you see things like this happening, that's because I'm doing that. Okay. Cool. So this is the app, and on the left you have the code for it. All right. So first thing we'll do, I already ran it in profile mode, right? Which means that I can go to Flutter Performance and turn on the performance overlay. It's all coming together. All right, so we have performance overlay here, and now when we do stuff, you see that the average frame per second on these 2 pages at least is just fine, right? It's all good. You also see that once we don't do anything, once there's now no animation, then the green bar here. I'm trying to. Okay. The green bar, this bar, is not moving because the framework is smart enough to be like, oh, okay, so nothing's happening. I'm not gonna work. I'm not gonna do any work. No. I was gonna make a joke, but so yeah. So this is that. So now the whole app is just progression of these pages, and some of them have terrible problems. And so the first one is just behind the blue page. Let's do it, right? Bam. Did you see it? I hope you did. It's on YouTube. You can rewind it. So that's a problem. Something took a long time and there was a jank. I did not see it myself, but if it was there, some people would see it. So what do we do? Like, how do we? Oh, okay. So we can look at the code and be like, oh my god, what are we doing here? That's so terrible. Well, we can use DevTools, right? So let's use DevTools. DevTools is something that you can run from the command line, or you can in VS Code and in other IDEs. You will find this little thing, which will open it. It will open in a web browser, like this one, and it will actually open at timeline. But there are other things that you can look at. We will use the timeline, and this is just my preference. I will go to the mode that is not show frames. I could talk about this for a while. I'm pretty sure in the next version of DevTools, this mode is not gonna be there at all. So anyway, it makes more sense to use the no show frames mode, which is like a actual timeline. I'm not making any sense, am I? So anyway, this is what you should be also doing. Let's just be direct. I like it. You should like it too. And what this timeline does is exactly what we're talking about with tracing. And so let's. I wonder if this is gonna be better. So I can be using my device like this, and I can record the timeline event. So I'll start recording, and I'll do something terrible. Bam. Stop recording. I'll wait for a while, and now I have that flame chart we talked about, right? And the flame chart is, a little involved, but let's break it down. Frame request pending is basically the Flutter framework wakes up, as I said before. At some point, Flutter framework wakes up and is like, hey, we need a new frame. And then these lines are, I'm waiting for the new frame to be built, right? Pipeline item, vsync scheduling overhead, let's not go into that. And then we have the UI thread. So these are not threads, right? These are things. The UI thread, and the GPU thread and the unknown thread. I've never seen that before. Okay, so UI thread is the main thing where run app goes, and the GPU thread will be ignoring for now, and that's the one that it's called the raster thread. Actually, it's called the raster thread, and it's the one that talks to the GPU and rasterizes your stuff. And generally you want to see something like this. Every frame, these are frames, is basically empty. The CPU thread is not doing much here, and it's just like, oh, okay, I'm done, and then nothing, and the next frame goes, and oh, okay, I'm done, and so on and so forth. This is cool. This is not it's not consuming battery, because you're not actually using the CPU for the whole duration of each frame. You're actually, let's say you're using like 10% of the CPU time, and also more importantly, you're never going over the kind of the limit of the frame, so that means that you are never janking, right? But then something happens here, and that's this terrible thing. Whoa, suddenly we have a frame that is really bad. Okay, and that's obviously this one. That's the one that janked a little bit. And okay, what do we do now? And as you can see, there was at least one skipped frame. So how do we deal with this stuff? Well, we can have a look at I wonder if we want to track widget builds. Yeah, let's do it. Track widget builds gives you more information down here. Like here, it just says build, and that's it. If we record again, with track widget builds on, we will see more information about the stuff. So let's do it. So I need to go somewhere else. Record, bam, terrible jank, stop, and now we have this, very similar to before. Everything is okay before, everything is okay after, but at the time when we actually show that one frame, we have something's going on. Last time we only saw the bar charts up till here. Now we also have, like the blue page was being prepared for this long, and there's like my rounded card and all that. So now let's finally go into the code and see what was happening there. Blue page. The blue page looks like this, and you can kind of immediately see the problem. The blue page is just my rounded card, which is this thing. That's just for it to. I wanted to give some space to the performance overlay, and then there's a list view with 10,000 items that are all built at the start, right? Because generally, that's why we kind of ask you to maybe use listview.builder, because that means that we don't need to do all that work at once. Listview.builder will call your build method as you're scrolling down or up your list view. Here we're not doing that at all, and we're just like 10,000 times we're running the build line widget method, and the build line widget method is a method that's also, it looks like a build method, but it's a method that we're calling, and it's constructing 1, 2, 3, 4, 5, 6, 7, 8, 9 widgets, right? So basically, when we did this, we constructed 10,000 widgets. 90,000 widgets. 10,000 by 90,000. So the first and obvious remedy is using list view builder. If for some reason this is not the case, for example, it's not an actual list view, at least don't use a method that you're calling, but use an actual widget. The thing is, if we had a widget called like line item or whatever here, and that widget would just have the same thing. It would just have padding and everything in it in its build method. Then the Flutter framework at the very least can be more clever about actually building the widget, because it sees, oh, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So about 11 widgets are actually visible. So I will run the build method for the first 11 or 15 or whatever widgets that I need, and I will just construct the line widget for the rest, for the 99,000 other widgets, and when the user scrolls to them, I will run the build method on them, right? So that's why sometimes I say, instead of just using a method, just create a widget, and that's it. All right. But this is not generally, the big problem with any app. You again, don't prematurely optimize, and if you see something like this, most likely you just need a list view builder and you're fine. All right. By the way, I don't know if you saw it, but sometimes you see like the GPU's taking way more than normal, or it's not that. Even just like going here, why is one frame slower than the other, right? You see that some of the frames are faster, some of the frames are slower. This is why you need to kind of have some better measurement and like look at it statistically, because there's so much going on in any device, and so sometimes it just will spike. The GPU meter will spike up because the device decided to spin down one of the cores or something like this, and suddenly everything takes longer. Or this actually happens quite often, more often than you'd think. The system will like make a CPU go slower because it wants to conserve battery, which is a good thing. But if you look at the graphs and just the graphs, it would seem like your app is suddenly slower. It's not. It's just trying to conserve battery. If there's any indication that the user would not get the frames that they need, 60 frames per second, for example, then the operating system will again kind of pump more into it. Okay, next one. So again, if I go to the screen, I see a spike, right? Let's go to the DevTools again, and let's clear this and record and do bam. And once again, we will have normal good timeline with a bunch of very short events, and then one big event that's this one. And now again, we could look into the actual code. Should we? Oh yeah. Let's look at the actual code, right? So this one is yellow. So here you can see kind of the similar thing like before. We have a list, and it's a list view. It's not a builder, but in this case, it's not such a big deal because there's just, I don't know, 25 lorem ipsum things going on. So 26 widgets, that shouldn't be that much of a big deal, right? But let's look at the widget itself, and then we look at the widget and it's like, oh, there's a container, there's a row, some size boxes, okay, there's an expanded column, padding, text, we're making subtitle. nothing wrong with this one, right? And so we're stuck. What's going on here? And that's why DevTools and before that Observatory is super good, because you can look at some of the items here, like for example the whole frame. I'll just select the whole frame here. Is this, can you see it? Yeah. I'll select the whole frame, and then then this tab thing on the bottom will give me a bunch of little things, like the flame chart, the CPU flame chart here, which we'll not be using today. The call tree is like, how much time did we spend in different calls, like run, which doesn't also give us a lot today. But then there's the bottom up. And if you go to the bottom up, you'll see, 42, like 12 milliseconds were spent in a method called Fibonacci. And that was called by a method called Fibonacci. And that was called by a method called Fibonacci. And so on and so forth, right? That's weird. And you see other things took some time as well, right? Like write string or replacer or perform layout. But like 0.31 milliseconds for perform layout, and something called Fibonacci is taking 12 milliseconds? What's going on? So we can just go and be like, okay, so where's the Fibonacci here? And okay, so we actually have a Fibonacci, I hope you can read it, Fibonacci method here, just below the just below the build method. And in general, again, in a real world app, this method could be somewhere completely different, but you would still find it in this view, because if it was taking so much time. So here's a Fibonacci number computation that is, the kind of the most naive, the basically probably the slowest approach that you can have. Fibonacci is just a mathematical number. There is no reason why we would do something like this, but we're trying to be very kind of readable here. And it turns out that if you look at these subtitles here, it says a number at the end, and these are all Fibonacci numbers, and they are just crazy, like hash code of a reversed string, modulo 40, and Fibonacci of that. So a lot of computation for every of these things, right? 26 things. So obviously it takes a long time, right? And now we know where that time went. I also have a to-do item here, and that is exactly this, that what I talked before, the timeline. So I could be like timeline and import start, something like make subtitle, and just before returning we do timeline finish sync. And this, if we rebuild the app in profile mode and started it in running, then going to this screen would give us the make subtitle event here, right? So we would actually see it among other events. And in our case, we already know what's going on, but in some other cases, it might be a very good thing to have. Okay, let's go to another problem. Which one is this? Oh, all right. So here we have, as you can see, nothing. Ooh, see, this is why I'm telling you that sometimes things just go crazy. But normally, nothing terrible is happening. We're not skipping many frames. Of course, now we're skipping many frames just because I said so. I said we don't, but generally we don't. But then we rotate this list and see how much work the CPU is doing. We're basically skipping every frame, or sometimes more than one frame. So that's not good. Let's have a look at green. So what we have in green is this button, the rotate button, will start an animation from 0, which is the rotate animation. And then we have an expanded, and then in it we have an animated builder that takes the rotation animation. And then there's a builder here that just rotates a big list view of 20,000 items. All right, so what happens here, and here we need to kind of know about what the Flutter animation framework actually does. The Flutter animation framework is a way for you to rebuild part of your screen or part of your UI, the widgets in the UI, every frame, right? So if you have like an animated builder somewhere or animated widget or whatever, it just means I want to change something when the animation is running. I want to change something every frame, 60 frames per second, 120 frames per second, whatever. So in this case, what it means, because we're using animated builder, is when rotation is running, which we do by tapping rotate, we are running this builder every frame, and that means we're creating a new widget. That's okay. We're creating a new widget below it. Fine. We are creating 20,000 items in a list view with 2 widgets in it, right? Or 3. 2. Obviously, really terrible. So what we need to do here is, I mean, again, I'm trying really hard to, you know, make this as bad as possible. But basically, you will see here that I am, even though I'm just rotating a list view, I am recreating the list view every frame, and not just the list view, but also all the 20,000 paddings and texts within it, right? And this is why we have the what I call the builder child pattern, where you see I'm not using this weird parameter called child, and you'll see this all over the place. You would often, for callbacks like this in animated builder and in other widgets that come from the framework, you would see context and child, and the child is coming actually from the animated builder. So you can be like child, and then take all this, the part that is not actually changing in the animation itself. So you take this, put it here. This means that it will, the list view, again, it should be a list view builder, whatever, but it's going to be only built once as we come to this page, and not as we are rotating it. And then what animation builder does is, it's like the widget itself, it creates its child, or takes its child, and then for every iteration of the animation, or for every frame, it will just give you the child. It will give you this, right? So you don't need to do it here. So you just do child instead of that. So basically it's equivalent to what we had before, except this time around we only build the list view and all its terrible amount of children once, and then just give it to the transform rotate, while before we didn't. So, and again, we can rebuild in profile mode and try it again, and we would see improvement, but we're not gonna spend time looking at Gradle, building stuff. So let's not. Okay, let's do another one. Which one is this? Okay. Okay, so here, this is something that will not happen again, so I need to kind of wait here. But what's going on here is that you see quite a lot of work here, but also on the GPU thread, and that's even though this is brown or orange. Oh yeah, this is orange. So even though the actual page is very simple, right? So you have just row. Oh, picture line. Okay, so now you have a list view again, and you have just a few 25 picture lines, and a picture line just is a padding with a row and an image asset in it, a small one, and some text, right? Why is it like none of this is expensive, right? Like what's going on? The problem here is this. Can I just see, like all these things. I mean, it's not actually janking, I don't think, but it definitely is for something this simple. It's taking a lot of time, and there was some stuff around this. And the reason why is let's look at the asset like Filip 2, right? Do you see this? 3,000, like it's a 2.83 megabytes of my face. You can be like, oh, great. Oh, this is terrible. Wow. And it's still like I still can't see the pixels, or can I? Anyway, it's just terribly big. This is a huge picture, and then we take this huge picture, and where's orange? And we use it for a size box, in a size box that is 70 by 70 pixels. Terrible. So we are basically like wasting so much time and memory that Flutter needs to do a lot of work to just like show a few stupid faces. The thing here is, so what needs to happen? And this is not just Flutter. Like any other framework would have to do this as well, right? If you have a 2.8 megabyte picture, then Flutter during a frame or something needs to go fetch that picture from the device, from the disk, basically. So that's 3 megabytes, kind of like, reading 3 megabytes of disk. Not that much, but still, we have a bunch of those and so on. Definitely costs, if not frames, it costs, it's actually not being done in a UI thread, but it definitely costs you battery. So whichever where, then it needs to decompress the JPEG into pixels. Then it needs to size it down to the size that it has there, and then it needs to send it to the GPU to render on a texture. So all this work for this little thumbnail. In this case, the best way to work on this is, or to make this better, is just use thumbnails, right? Like if this is what you really want, if you really want just a 70 by 70 and a little list of icons, basically, or thumbnails, then make sure that your assets are comparable size, and you don't ask the Flutter framework or any other framework for that matter to do all that extra work for nothing. That doesn't mean that you cannot have 3 megabytes of assets, but just don't waste that. All right, that's the orange one, and then yeah, I wonder how I am on time. Oh wow, I am actually terrible on time. Have I spent more than an hour already? Okay. Well, we're coming to an end. Hopefully you're not sleeping yet. I don't know. Okay. But anyway, sorry. I didn't realize it's so I'm taking so long. Okay. Let's do the next one, and that's the compute thing here. So let's try to compute something. If I compute here, you'll see terrible jank. And again, this is a Fibonacci thing, but like, why is it janking this much? I think it's pink. All right, so here we have a flat button, that's the compute button, and when you press it, it starts a computation. And then we'll get to that later. And then, yeah, Linda says, I've spent 1 hour and 15 minutes. Wow. I thought I would be done by now. Sorry. So we are starting computation, and then below it you have the result text, that's this one, and then if result is null, we show the circle progress indicator, and then when we have an actual result, we show the result in a big font. Okay, so, and again, I can do this and it will jank like crazy. And so what's happening in start computation? It's an asynchronous method. Okay, it's an asynchronous method which first assigns null result to null. This is so that we show the circle progress indicator, and then it waits for 200 milliseconds. This is normally you would not do this, but I just wanted you to see how the circle progress indicator starts spinning and then just janks, and then it computes a number, and then again it's waiting some other time so that, you know, again you see that 200 other milliseconds of the jank, and or after the jank, and then it sets the result to the result and you see the number, right? So for many people that this is weird because we're in an asynchronous method. Why is this janking, right? And if you look at the Fibonacci, that's the same thing. It's actually using BigInt, which is, you know, like if integer 64 is not 64-bit integer that just comes with Flutter is not enough for you. Flutter also gives you, not Flutter, Dart. Dart also gives you BigInt. It comes with the core library, and BigInt is just like arbitrarily huge integer. And it's slower to operate with, but it's like it will never it can be arbitrarily long and large. Anyway, so you will you should see that even though we're running this in an async method, the Fibonacci method itself is not asynchronous, and this is where we spend most of the time. It's just, it starts running and it runs and runs, and it consumes a lot of resources to, you know, compute this one simple number, and then when it's done, then we go back and we await and do all that stuff, right? So again, let's do some profiling here. We will record and then start computation and then stop recording, and we see something that we haven't seen before. Before, whenever there was a problem, it was a problem of like a build method, right? So like the build method was very large, or the frame was very large. Here, frames are fine, but then we have this message loop flush task. By the way, message loop flush task is on top of all of these things, and it's basically just saying this is Dart running. This is Dart in the UI thread running. Whenever there's something like this, it's just some computation that was started by in that thread, right? So there's some unknown huge computation, or well, we already know what it is, that is taking place all this huge amount of time. Let's see how much that was. Yeah, 673 milliseconds, if I'm understanding correctly. We just did this, right? And this means that, look at this, frame request pending. Generally, the frame request pending is just like, oh, we need another frame. Oh, we have it, fine. Here, because the Flutter framework didn't even have a chance to do anything, the frame request pending was this long, and it missed so many frames, right? 766 milliseconds before 2 frames, but between 2 frames. Terrible. So so you should know about this. And again, we can look at the bottom up and we can see that compare digits is something that's coming from the begint class, and it's just a bunch of Fibonacci basically things. We can do the call tree here. I think we will have more luck, maybe not, and the flame chart will give us something more interesting. Yes, right? So you see a bunch of Fibonacci things here. Oh, this is nice. I like it. Anyway, so we are obviously, even though we are doing all this work in an async method, and we are not even starting in the build method. This is when the user presses it. Because this part is not asynchronous and it's in the UI thread, it will block everything else from happening, and it will just change the whole app, right? We can, like, the easiest way to fix this is to use another thread, another isolate. I will just show you how that would work. So Flutter Dart gives you a way to create isolates, which is basically new threads that are isolated from the other threads. Flutter kind of wraps it up, and it gives you an even simpler way to make these new threads, and it's called the compute function. So compute is coming from Flutter Foundation, so it's coming with the SDK, and the compute function is asynchronous. But more importantly, why is it saying that? There's no. But more importantly, it creates for you an isolate, and then you can do whatever you want. You can run a function in that isolate and then get the result back. So in this case, we are going to give the Fibonacci the function itself, and then what was it? Begin 32, was it? I think that was it. And again, I would have to rebuild the whole app to show you that, but basically it would still take the same amount of time, but nothing would stop. The little circle progress indicator would still be spinning, because now what happens here is when we hit the compute function, Flutter will create a new thread. It will tell the thread, this is the function that you should be running. This is the data that you should send to the function, and when you're done, give me the result. So the Fibonacci thing runs on the separate thread. It will not block anything. When it's done, it will return the final number as a begint, and the compute will tear down the isolate or tear down the thread. It will give us the result. We delay for another 200 milliseconds, and when we set state, and everything is just fine. Okay, now I'm getting even more. I'm taking so much time. All right, we're getting into the even more obscure stuff, and this is the things that are like expensive widgets, right? So in this case, the main thing is we have just a normal page, but the page has like a bunch of shadows that I don't think are really adding much. Shadows, blurs, overlaying capacities, all these things are something that you will see in the raster thread as expensive, and it's something that you can look at and be like, okay, so maybe I can tone it down. In terms of shadows, often what you really want is just just use something else. Sometimes you can pre-compute the shadow and stuff like that. All right. Another expensive widget is blur. I don't think I've told you that. This is another rotate thing, which is like terrible, but it's last time we saw a rotate problem, it was on the CPU thread. Here it's on the raster thread because we're blurring the whole list view here. So just use blur sparingly and don't reapply blur every frame of an animation, right? I just want to show you I think it's Indigo. Yeah, so it's like there's a rectangle here which clips the actual part there. There's a background filter with a image filter blur, and below it here is the widget with the list view. So the only reason why this is slow is the blur. Ooh, let's do some memory profiling. So here we have something that just generates lots of messages, right? And we can actually, this is less of a problem that you'd think, because as we start scrolling, you see that the UI is actually very responsive and we're not missing frames. That's fine, right? But as I said previously, the operating system is trying to be like, oh, nothing is changing. I can actually make the CPU go slower so that we're not using so much battery power. So this is actually fine. It looks terrible, but this is actually fine. What's the issue here is if I go to the memory tab of the DevTools, and if I don't look at the external memory, which is the external memory is used by images and stuff like this, I can see what's happening here is that, like, as I'm running this, there's a lot of memory taken, and then there's like Dart wakes up and says, oh wait, we have so much memory, let's run the garbage collector, the GC. Right, we can do snapshot at any time, and we see, oh, okay, so these are like the different objects that we have in memory, and we will see that like there's a 200 kilobytes taken by something called date format, right? So, and this is again like we actually this is something that I took from someone else and made sure that there is a memory leak here. But it's not a memory leak, but it's a memory something. I think this is Lime, and it's like, okay, so we're doing that whole logging thing. Why are we spending so much memory on date format? Sure, we're the VM will, or the Dart will free the memory later, but it's still a lot of memory being kind of like lugged around, and it's all taken, almost all of it is taken by date format, which is kind of weird. So we can look here and we can search for date format. And we see that, okay, so every time we do a new lock, which is several times per second, we create a timestamp for that lock. And that timestamp has a time, date, meridian, which is basically something like, 9 o'clock p.m. That's the meridian of this date. And then for the formatting of that timestamp, we're using date format. Date format, that's what it's about, right? Like you have a class that can make that can format time for you or date. The problem here is, and some of you may see it already, but it's kind of not obvious, is that because these are not static, because these are in the class itself and they are not static, we are actually created the date format for every timestamp anew. Even though they're always the same, we're creating those anew. So the easiest thing to do here is just to put them here, or if you absolutely must have them here, you can just make them static, which means they will not be created for every instance of the class. And suddenly you're using way less memory and you're all happy. All right. Finally, I'm getting to the end of this, and I know many of you will have questions, and I just want to make sure that I'll finish it, and then we will have time for questions. If you can make it, you have other things to worry about. Thank you for staying with me so long. This will be on the internet, on YouTube as a thing, so you can definitely look at the questions later. So sorry again, but what I want to do is to talk about the black page, and the black page is this. You can see this, right? So there are two animations here, A and B, right? So as you're sitting and watching at home, which one do you think is faster or more performant? I'm actually gonna remove this because it's just distracting. So this one, A or B, right? Because of the nature of the YouTube streaming, if you're replying now into the chat, I will see it way too late, like a minute from now. So I'm not gonna actually wait for your replies. But for most people would say A is kind of slower or sluggish. But what actually is happening, if you look at the code, these both take the exact same amount of time. So you have duration of 300 milliseconds for both A and B, but the only thing that is changing is the curve. The first one is linear. So, and that's again similar to what I said before about the like physical aspect of user interfaces, where things that look kind of robotic look slower or less performant and just more terrible, while things that are going like with this, for example, ease out cubic curve, are looking much better. So and the only thing that is different here is the perception. It's the same speed, it's the same amount of resources taken. It's just that here we're using the linear curve to move that object around, and here we're using the ease out cubic curve. So if you're wondering what does this have to do with performance, this is basically often the reason why some apps look sluggish. Some apps are amazing. They're not actually using any more resources. They're not actually skipping any frames, but they somehow feel bad. They don't feel as performant as they might. And the only reason is that the developer behind them did not take the time to use the right curve. Linear curve is the default. It will be used by default if you will not like give the animation builder or whatever a different curve. So here we're like, oh, okay, so there's a twin animation builder, and somewhere here we're using where are we actually using that curve? Widget curve. Oh yeah. So see, the twin animation builder is just using the curve, and you can also translate another animation with a curve. So do use curves and do use things like ease out cubic, because it looks much better. All right. Okay. So I'm sure that you're not. Well, I mean, thank you for listening for so long. This was really the last one. I don't think I ever got to this in an actual presentation. So I'm generally terrible at keeping time, but this is pretty bad. Let's have a look at the questions from you. So I'm gonna do this, and thank you. So thank you so much, everyone. Thank you for watching. And because of the again nature of the talk, let's wait for some of the questions. Let me actually do this and that, and let's look at questions. So question number one, I asked the co-organizers of this event to give me questions that are interesting, and so please do ask more questions as we go, but I will kind of look at the questions that were asked during the event. And again, I'm sorry for taking so long. I felt if Flutter apps freezes for more than 5 seconds, then also we don't see app not responding ANR screen. But in case of Android native, we get that ANR screen. What is the reason why? So that's true. If you have an Android the platform native app and there's some unresponsiveness in it, then Android will learn about this, and it will show you a little screen that says like, oh, the app is not responsive. This does not usually happen, or maybe never happens with Flutter. The reason is, again, the way that Flutter is very low level. So so Flutter is like, you can think about Flutter as Unity but for apps, right? It's pushing your pixels straight to the OpenGL surface. The same way a Unity app will not use the ANR thing, a Flutter app will not as well. Because from Android's perspective, your Flutter app is still an app. It still sees all the accessibility things. It sees the buttons and stuff like this. But you are not using the system widgets to show anything. So you're on your own thread, as I said. Like the UI thread of Flutter is different from the UI thread or main thread on Android. So your Android will not actually detect it. So it's not good or bad. It's just the nature of the system. Another question, new to Flutter, would using a list view builder be considered a premature optimization in Flutter? That's a good comeback. I think it will probably make sense in most cases where you have a long list, and it's not that much big of a difference. So you should be thinking about it. If you have a small list, 25 things in it, then if making a list view instead of a list view builder is easier for you, then for sure go with that. Flutter on web also janks a lot on mobile devices, but it works just fine on the PC browser. Can there be something wrong with my code? Probably not. So Flutter on the web, is in an early stage, and also it's running on the web. So it's using currently most of it is JavaScript, some of it is WebAssembly. So it is going to be slower than using the ARM code. Like if you're making your app for a device, iOS or Android, then we're compiling straight to machine code. It's like running right on the metal, and then we're just like blitting to a graphics card. With Flutter Web, there's way way more stuff going on before your pixels get to the screen, right? So we compile to JavaScript, and then we are like sending things to like the DOM, and the DOM needs to do that and stuff like this, right? So there's definitely more work that is being done on making it not slow, but it is understood that things on like Flutter on the web will be slower than Flutter on the mobile device when running on the mobile device. The reason why you're not seeing the jank on desktop is just our desktop or laptop is just because of how way faster desktop is generally than a mobile phone. So don't think that. Yeah, I mean, there's also Flutter for desktop, right? Flutter for desktop has almost zero performance issues just because like desktop computers or laptop computers are just way faster than any device on the market. Number 4, related to app performance, any tips to achieve smooth list scrolling besides list view builder? Sure. So like you generally don't want to. I mean, all the things that I said apply a lot to list views scrolling, and it's also often the main reason why people feel a jank, because they're actually using the scrolling and then it janks. The thing is, yes, use list view builder. Don't do like try to just optimize each of the items so that you're not doing too much. And also, if you have, for example, a state management thing, try to not rebuild the whole list view every time something changes. And that is actually not that easy to do, and that's a topic in itself. But often what we see is that something changes somewhere, like the user taps on the favorite star, and then unwittingly maybe the developer will like rebuild the whole thing because of the state management way they're doing things. So don't do that. But yeah, nothing else comes to mind. How to implement performance test automation to avoid regressions in performance. All right, so Flutter framework itself has a system for this, but that's way too like that's not usable for a normal app. I will also close this. But I'm really hoping that either the community or we will come with some tooling that will make this easier. I have that. I told you before about that article I wrote, Flutter performance testing. Is that right? And it's actually pretty involved. This one, so that there's really no easy way, and is also one of the things that is not specific to Flutter. Like it's generally really, really hard to do performance testing on that is like regression testing, and it's continuous and stuff like this. I wonder if this is something that we could be or should be working on in the next months, because obviously the ideal, if you know Flutter benchmarks. Wait a minute. Do I? I'm sorry, I'm trying to find. Oh, yes. All right, so I think I'm ready to show you. So if you go to this address, I don't know if many people know this. This is kind of what I would like for a normal app, but this is for the Flutter framework itself. And the funny thing is that it's the app itself, the benchmarks app, is slow and takes time. but it's fine because it's not for users, it's for engineers on the Flutter team. But basically, when it loads, if it loads, it will show us a bunch of these regression tests, and it will show like, oh, this screen or this widget takes this much time to build every frame, and it's going down or up, or like the last thing that happened went over a budget or whatever. So I'm gonna put it in the chat. Oh, there it is. I'm gonna put it in the chat here. This is, like, this is analyzer benchmark, so it's not related to something like that, but build, right? So you can see, like backdrop filter perf timelines is and you can see how it went and what's the call, what's the baseline, and how like different how noisy it is, to be honest. Here you can see, build benchmark is this, and this one revision went way over that, but generally it's going down, which is nice, and so on. Anyway, so that's what you want for an actual app, where you can look at some dashboard like that and be like, oh, things are going well or not. All right. Another question: how to implement performance test automation to... Oh, that's the one that I just answered. Okay, I think that we're done here. Thank you so much for watching. Thank you for the questions. Thank you, Martin, Jorge, and Mariano, for organizing and moderating, all that. I hope this was useful. I hope that you got something from it. I hope your apps will now be blazing fast and will not consume any memory and not get any battery and things like that. I also am super happy that the Flutter community is as active and kind of cares as much as it does. So it's always great to see and hear about all that. And thank you again, and I will shut up and let you have your week. Not the week, but I will let you have your evening. Thank you.